Yeah. So today's topic is component of effective data architecture. So as part of today's agenda, we are going to discuss about introduction to data structure, then the roles of data in AI/ML initiatives, then data architecture overview, key component of data architecture, then data quality, ensuring clean and accurate data labeling, preparing data for machine learning, then talk about the role of data context in architecture, then data storage, data recovery, data protection, data governance, data integration, data modeling, data pipeline, okay, how ensuring a smooth data flow, okay, from source system to destination system. Then we'll talk about optimizing data architecture for performance, then challenges in data architecture, future trends in data architecture, then summary and best practices. Okay, clear. So these are the things we'll discuss as part of today's agenda. Okay, let's start with the first one, that is introduction to data architecture. Introduction to data architecture. Fine. So let me go back to my PPT and yeah. So here basically we talk about what is data architecture. The blueprint for organizing, managing, and storing the data. Basically, we call it a data architecture. Ensuring data is accessible, secure, and usable for various business processes. Real world example, how companies like Amazon or Netflix manage vast amount of data to the power recognition. Okay. And why it is matter? Why data architecture is matter? Is matter to organize the data or store the data in a regular fashion and a proper manner, or I can say proper way, I can say. Suppose, okay, the support data driven decision making, enable AIML initiatives, then facilitate data governance and security. So going forward, we'll discuss everything. What is data governance? What is security? All about. Okay, everything we'll discuss. Okay, so let me go one by one. Yes, the role of data in AIML initiative. The overview of AIML need. As you know, AIML, that is artificial intelligence and machine learning model, rely on heavily on structure, clean and context-rich data. Real world example, Google search engine, which are built on a vast amount of data, continually improving through machine learning. Data requirement for AI like volume, variety, and velocity. So it depends upon three V's actually. Okay, data requirement. One is volume, then variety, I mean types, and velocity, speed. Okay, the data architecture role ensuring availability, quality, and structure for seamless integration with AI/ML system. Now, architecture overview, definition or defining data architecture. The structure that support all data flow and storage, retrieval, and users. How data is modeled, integrated, and stored and protected. This all comes under the data architecture. When I'm telling data architecture, it's not about just a diagram. It's all about how data flow, whether it's a streaming data or batch data. I mean, it flow continuously 24 by 7 or like batch wise, like at certain time it will flow. Then how we are storing, whether we have implemented any caching mechanism, partitioning, bucketing and all, or just normal storage. The retrieval, how we are retrieval data by using the sealed query, whether we are using any optimized searching operation, that also very matter, and uses. Now, how data is modeled, integrated, stored and protected. Basically, I'm talking about the data privacy, how data is protected, whether we are giving some extra security layer or not, like authentication, authorization, any permission, role access we have given or not, like write access, read access, edit access, modify access, everything. Okay, and how data is modeled, how we are building the model out of the data. Okay, that all comes under the data architecture. Now, real world example, how Uber manages that architecture to ensure real time trip data is available to both driver and passenger. Importance of both batch and real time data pipeline. Okay. Like sometimes before I was talking about, right? Batch data means page by page. For example, a job will run at let's say 3 p.m. every day. So at 3 p.m. a job will trigger and the data will come from the source system and come to the destination. But if it's a streaming job, as soon as the data will store in the traffic, it will start receiving and come to the destination end. Now, the core component. Like coming to the data architecture, basically it contains 4 to 5 different core components. One is data source, that is either internal or external data source. Data integration, we are using different kind of ETL tool for data integration. Okay, then data storage, it may be database, file system S3 or data lake, whatever it may be. Then data processing, data pipeline, transformation tool, and everything that comes under data processing and all. Then data visualization, we are using different type of BI tool, either Power BI, Tableau, visualization tool, like maybe Excel we are using also. Okay, for creating some different dashboard, so that it will help client or end user to take business decision. Okay, so we are creating different kind of dashboard and we are displaying the output in front of end user. Now, a real world case study. Microsoft Azure Data Architecture, a holistic view of their cloud solution, combining storage, analytics, and processing. Now, why data quality is critical? Sometimes before I was talking about, whenever we want to build the model, we need a clean data, right? So let me come back to my whiteboard. Let me explain. Now clear? Now let's come to data quality. Okay. Data quality is talking about the accuracy, completeness, consistency, timeliness, and validity. There should not be any error in the data. There should not be any missing data also. That's all about data quality. Let's say, for example, more number of data are missing, then I can say the data quality will be reduced. Obviously, that is not that much a great data quality. So there should be very less minimum amount of data missing. Okay, completeness of the data should be there. So data should be fully complete. Okay. Now case study. How poor data quality in healthcare lead to flawed prediction in hospitals predictive analytics model. Because in hospital sector or medical domain, what happens? Whenever we are building any data pipelines or I can say model, data should be complete. Very less amount of data should be present, or otherwise it will create the hallucination problem. What do you mean by hallucination problem? Maybe data quality is not good, but it will behave that data quality is good and it will give certain accuracy. which in real time that doesn't make sense. Okay, it will drop. Okay, so it will create a lot of hallucination problem altogether. Okay, now Microsoft Data Quality Framework for Azure and all. Now data labeling, preparing data for machine learning. What is data labeling? The process of tagging data with meaningful labels to train models. Example, labeling prototypes of cats and dogs for a machine learning algorithm. Real world example, label box data labeling platform, which helps organizations prepare data for AI/ML project at scale. Importance critical for supervised learning model. The cost and time involved in high quality data labeled. Okay, so data labeling basically I will explain. As part of machine learning, there are two different concepts. One is supervised machine learning and unsupervised machine learning. In supervised machine learning, generally we use the label data. But in unsupervised machine learning, we use the unlabeled data. That will explain, okay, going forward. You can see, yeah, supervised and unsupervised learning. So in supervised, which comes under the regression and classification, both use the label data. Unsupervised machine learning, which use for clustering, which use unlabeled data. I mean, labeled data is not required. Okay, labeled data is not required. Now coming to let me come back to my whiteboard. Let me explain, give a brief idea. Okay, what is that machine learning and all? Generally, guys, this is the machine learning trend. You might have heard about it. Machine learning. Okay, machine learning. Let's say entire algorithm. Okay. Now coming to machine learning, guys, is basically of two types. One is supervised ML. Another one is on supervised ML. Supervised ML and unsupervised ML. Okay. Generally, as typical speaking, there is another type, that is a reinforcement learning, but that is not that much important as part of our curriculum. So that's why I'm not dividing. Okay. So make it two types. Okay. Now coming to supervised machine learning, guys, it is of two types. Again, two types. One is regression. Another one is called classification. Similarly, coming to unsupervised machine learning, it is of clustering and other things are like dimensionality reduction technique. Okay, dimensionality reduction technique. Okay, we are using PCA and all. Fine. Now, generally, what happens whenever talking about labeling, the label data we used in the supervised, that is label data we used for supervised machine learning. That means we use for both regression as well as classification. But coming to unsupervised machine learning, we use on-label data, on-label. Okay, on-label data we use for unsupervised, which is again, I can say, we are using for clustering and dimension reduction. Now, I'll show you an example how, in case of classification problem statement, we are using label data. Okay, basically I will give some animal, okay, with a label name. I'll give to a model and I'll give a unknown data set. It will predict whether that particular animal belongs to either elephant or camel or cat or dog or whatever name. Similarly, I will give on label data set to a clustering. It will not directly tell, okay, what that the particular animal belongs to, but it will tell it belongs to that particular category, like clustering kind of things. Clustering this kind of cluster, which classes and all. Okay, fine. So let me go back to my PPT again. Very interesting. Give your 100% concentration. Yeah. See what guys I'm doing here. This is a supervised learning, as I have drawn that hierarchical diagram. in my whiteboard. So this is a part of machine learning algorithm. Generally, in this case, I am using the label data. How are you telling label data? You can see the input raw data I'm giving. So you can see the combination of some elephant, camel, and a cow. And here I will label also. You can see here I'm telling okay this picture belongs to elephant, this picture belongs to camel, this picture belongs to cow. Now what happens? I am giving this training data to this algorithm. Now, the supervisor, I'm designing the output. Now, as part of processing, guys, I'm giving certain images. Maybe kind of this image, this image, this image. Three different animal category I'm choosing and giving. Now, my model is predicting, hey man, this picture is nothing but called elephant. This picture is nothing but called camel. And this picture is nothing but cow. How it is telling whether it is a camel, why not elephant, why it is cow, why not this is camel? Why? Because whenever I'm training on top of the data set, I'm giving the hints or information to my model saying that hey, the image or the animal looks like this, having a long trunk or like a long teeth or maybe long tail or heavy in weight, black in color. Okay, this is called elephant. Okay, then a camel, something like concave shape on the middle of the backside, tall in shape, long neck. You can see long neck. Okay, and that is not long trunk, obviously. And the color is like a sand color. Then that belongs to camel. Then cow. The combination of white and black color, not that much tall, not that much heavy like elephant, no long trunk, no long teeth at all. It has two horn also. If I such type of diagram or such type of feature you are telling, saying that belongs to cow only. So indirectly, I'm training my model by giving the label data set. That's why whenever I'm giving a similar unknown data, my model is predicting and deciding, hey man, this picture belongs to elephant, this picture belongs to camel, and this picture belongs to cow. Getting my point, guys? That is what is happening here. Similarly, in the unsupervised machine learning, guys, what happens? Think about this. Here, as I told you, unsupervised machine learning means it is not labeled data, unlabeled data. Means I'm not telling this is elephant, this is camel, this is cow. I'm just giving and training to my model. Now, suppose here I'm giving some unknown data set like previous one, like this. Okay. Now what happens as part of output is just segregating into different classes. Okay, this kind of category belongs to one. This kind of animal belongs to one category. This kind of animal belongs to another category. But here, one important thing missing is not labeling. It's not telling this belongs to elephant, this belongs to camel, this belongs to cow. Why? Because I am not told to my model saying that this is my like elephant or camel or cow. It may be goat, a cat, a tiger, whatever it may be. But in the previous example, as I am telling indirectly or directly to my model, that's why my model is not only distinguishing but also giving the name which classes it particularly belongs to. But here there is no name, just only classification. Getting my point, guys? Any doubt so far? Any doubt so far? Clear, clear. Now go to the next one. Yes, clear? Let me see your chat box. The role of data context in architecture. What is data context? Try to understand. Understanding the meaning and the relevance of data in its environment. Example, how a user location in a travel app changes the data's context. Why data context matters. Ensure data is interpreted correctly. Helps in accurate decision making and insights. Real world example. How contextual data from sensor is autonomous vehicle help in decision making. Okay, because like nowadays self-driving car come into the picture that develop on top of the deep learning technique altogether, right? So that's how it's emerging. The technology are emerging. Now, data storage, choosing the right storage solution. As I told you, as part of the storage, we can use either database, data lake, file system. Again, coming to database, two type of database, either relational database or RDBS, or I can say NoSQL database or cloud storage also. Okay, so based upon our requirement, we can choose different kind of data storage also. Okay, now how to choose the right storage solution based on the data volume. Okay, based upon the data volume, velocity, and variety. Trade-off between performance, scalability, and cost, because that everything matters. Whenever we were planning to choose any product, we are not seeing only just performance and all. Everything there should be a trade-off between performance, scalability, cost. When I'm telling scalability, again it's vertical scalability or horizontal scalability both. Performance means high performance or a medium performance or low performance. Everything we have to consider, we have to take into consideration. Okay, before choosing any software or product. Now, real world example: how Airbnb uses Amazon S3 for storing massive amount of unstructured data. Example: user review, photos, and all. Okay. Now, data recovery, ensuring business continuity. What is data recovery? The process of restoring data after an unexpected event, example server crash, cyber attack and all. That is called data recovery. Recovery means just covering back. Okay. Key element of data recovery: backup strategy, disaster recovery planning and all. Now case study: how AWS implements multi-region backup to ensure data recovery in case of natural disaster or failure. Because always the backup is always there, whether it's a database or any cloud platform or any storage, we are giving always the backup support and all. Okay, so that we ensure that there won't be any missing of the data altogether. Clear? Now, coming to data protection. So as I told you, data protection. Again, we are giving different type of layer. Okay, let me come back to my whiteboard. Let me explain. Okay, let me go back. See, data labeling we have completed. Roles. Okay, data protection. We'll talk about data storage, data recovery, and data protection. We are here. Data protection. Okay. Okay. How we can protect the data so that any fraudulent transaction or any fraud they can hack our data. Basically, there are different layer we are implementing. There is something called authentication. Authentication layer. Let's say this is my data pair, coal mine. Okay, this is my data authentication layer. On top of that, authorization layer. So this is authentication layer. This is authorization layer. Okay. Then we are giving some security policy. We implement security policy. Then Access permission. Maybe we are giving some read access, write access, modify access, read access, write access, modify access and all. Clear guys? Read, write, modify. Okay. So different access permission, role permission, access permission, role permission we can give. Roles. Roles permission we can give so that we can protect the data altogether. Clear guys? Any doubts? Any doubts? What is data governance? The policies and practices that ensure data is used responsibly, ethically, and in compliance with legal regulation. Key component data, policies, audit, and all everything. Okay, roles and responsibility data management and all. Real world example: how IBM's data governance framework ensure compliance with international data laws. Now, data integration, connecting servers across system. What is data integration? The process of combining data from multiple sources into a unified view, that is called part of data integration. Generally, for that we are using some tool. That tool is called ETL tool. ETL stands for extract, transformation, and load. You can see extract, transform, and load. ETL. Okay. Now, real world example: how LinkedIn integrates data from diverse sources to give personalized job recommendation. Now, data modeling, structuring data for access and use. What is data modeling? Creating a visual representation of data and its relationship within the architecture. Types of data model: conceptual, logical, and physical model. Case study: how Netflix uses data modeling to structure, user preferences data for recommendation system and all. Okay, these are the different use cases we use for data modeling and all. Now you can see a typical diagram of a data modeling. As I told you, there are three different layers: conceptual, right, logical, and physical model. You can see the same thing is written: conceptual model, logical model, and physical model. So here my data is present. Now as part of data architecture design, I am creating different type of layer for the different type of model, that is design model of architecture. Then basically what happens, data managed by data architect for analysis and all. Clear? Now data pipeline. Okay, so let me come back to my whiteboard. I will explain. We draw a typical architecture diagram how data will flow. Okay, generally what happens? Let me use different type of layer. This is the architecture. Okay, source, staging. This is a raw and the directory discovery, refine, and this is my target. Okay, so this is my source system. Okay, this is my staging layer. Okay, this is my something like, let's say, or I can say this is my raw layer. Let me write the raw layer. A raw layer. This is my staging layer. This is my target system or destination. As part of source system, guys, what happens? So generally think about this is my database. My data will come and store here. Or maybe it's a file system. Okay, or maybe it's a cloud, whatever maybe. My data will come and store into staging layer. How? Through pipeline. So this is a kind of pipeline through which data will flow actually. Pipeline means think about the water pipeline, right? So this is a data pipeline. So instead of water, data will flow from source system to here. Okay. So this is data pipeline. Now here, let's say some S3, Amazon S3 we are using. Then again, I'm creating data pipeline from here. It will go and store into, let's say again, Amazon S3 in the Parquet format or Abro format or not. Abro format. And here the destination maybe I can say Snowflake or maybe any cloud-based system. Okay, either Snowflake, SF, or any cloud-based, let's say Amazon S3 also, or like a Teradata system or any SQL DB, whatever it may be. Okay, so this is Snowflake. It may be cloud environment like Amazon S3 also. Okay, so here also data pipeline. So data pipeline, data will flow. Clear, guys? This is the typical architecture of data pipeline. And how we are building this data pipeline? By using a tool called ETL tool. So ETL stands for extract, transform, and load. Generally, as it slowly developed, another tool come into the picture, same, just elder brother of ETL, that is ELT. ELT tool. What is the full form between ELT and ETL? Fast extract in case of ETL. Fast extract will happen, then transform, then load. In case of ELT, fast extract will happen, no doubt, extract, then load will happen, then transform will happen. Clear, guys? Any doubt so far? Any doubt so far? So these are the typical tool we use to build a data pipelines, by using which we consume the data from source system, bring to our platform for further analysis and whether to building data models or like analysis purpose and any other thing. Clear, guys? Any doubt so far? Any doubt so far? We should cover the next one is optimizing data architecture for performance. Okay. Optimizing data architecture for performance. What is a data pipeline? A series of steps to move and transform the data from source to storage or analysis purpose. That is called data pipeline. Key component of the data pipeline: data injection, data transformation, data loading, as I told you, ETL, like extract, that is injection, transfer, transformation, loading. Real world example. How? Spotify uses the data pipeline to process billions of user data point in the real world scenario. Now you can see the data pipeline ensuring smooth data flow. A typical diagram that I explained in the whiteboard Same things a beautiful, manually colorful diagram is showing here. First, data source. I'm extracting, keeping into the raw layer as I told you. From raw layer, I'm storing into the staging layer where all the transformation will happen. Then a part of data, prepare data, then loading into the target table that is nothing more my data warehouse or Snowflake or cloud based anything else. Then for analysis purpose, I'm extracting from the data warehouse or maybe Snowflake and load into Tableau or Power BI. That is data analysis here. Clear guys? Any doubt so far? Now, how we can optimize it? Optimizing data architecture for performance. Strategy for optimizing performance. First, what we can implement, there are three to four strategies are there. First one is indexing. Organizing data for faster search and retrieval operation, we're using the indexing concept. Similarly, storing frequently accessed data in faster storage to reduce retrieval time, we are implementing the concept called caching mechanism. What's about the partitioning? Dividing large data set into smaller, more manageable pieces for improved access. That is called partitioning. And what's about parallel processing? Dividing tasks and processing them simultaneously to improve speed and efficiency. That is called parallel processing altogether. Now, real world example how Facebook scales its data architecture to handle billions of interactions every day. That is all about the real world example, and that's all about the optimizing concept. Okay. Now, few challenges. What are the different challenges that we face as part of the data architecture? That is very, very important. Anyhow, what are the different challenges that we face? The first one is data silos. What does it mean? Isolated data storage that hampers data accessibility across system. Now, data inconsistency, this discrepancy between data set leading to unreliable or conflicting information, slow performance, delays in data retrieval and processing, affecting overall efficiency, lack of scalability, inability to handle a growing data volume and user demand. Now, real world example, healthcare institution and EHR integration. Challenges, integration, electronic health record, that is EHR, across diverse system, data silos, patient data stored in separate system, making access, difficult. Data inconsistency, variation in data format across healthcare providers, slow performance, delays in accessing patient record, impacting decision making, lack of scalability, difficulty handling large scale data from multiple healthcare providers altogether. Okay, that's all about the different challenges that we face as part of the data architecture. Then what is the future trend? It's very important, right? These are the challenges. Okay, fine, we understand. What are the different feature trend in data architecture? The key trends are cloud native architecture. First one, building application designed specifically to leverage cloud environment, ensuring scalability, flexibility, and resilience. Serverless computing, running application without managing servers, automatically scaling based on demand. Now, real-time data processing and edge computing. Processing data as it arrives and on devices close to the data source, reducing latency and enabling faster insights. Real-world example, hybrid cloud architecture. Challenges, balancing data privacy with the need of scalability. Solution, companies are adopting hybrid cloud architecture to store sensitive data on private cloud for privacy and security. Now leverages public cloud for scalability and cost efficiency. So these are the different feature trend as part of improvisation state we can implement that by implementing the hybrid cloud architecture and all native cloud architecture, serverless computing, real-time data processing, and by using Kafka or maybe Spark streaming and all. Okay, these are the things we can use for real-time data processing and all together. Okay, so summary and best practices. What the key takeaway we learn from here? Data architecture is the foundation for all data-driven processes. Emphasize the importance of data quality, production, and governance. Scalability, flexibility, and performance are critical to future-proof architecture because scalability, and maybe horizontal scalability or vertical scalability, flexibility, and performance, all things are important for us. Now, best practices. Okay, implement strong data governance, prioritize security and privacy, regularly evaluate architecture to meet business goal altogether. Okay. These are the key takeaway that we have. Guys, any doubts so far? Any doubts so far? Please ask. Okay, let me scroll off. So this thing we have completed anyhow. So what are the things left? Yeah. So challenges in data architecture we have seen. Future trend we have seen, right? And summary and best practices, that is key takeaway, that also we have completed. Okay, so this we have completed the first 1 hour, that is component of effective data architecture. Let me set the agenda for the second part. Okay, then we'll take a small break, and once we'll come back from the break, we'll continue from there onwards. Okay, fine. So let me pull down my second part. So now we are going to discuss about the technology and infrastructure. Okay. So as part of this, we'll see the different type of subtopic like introduction to data engineering, infrastructure, key technology in data engineering, data collection, data storage, data processing, data consumption, data visualization, end-to-end engineering workflow, then best practices. Okay, so let me before dig dive into each and every subtopic. Let me talk about what is data engineering altogether. Maybe you are hearing fast time. Some people are hearing fast time. Let me talk about that. Yes, in like job profile, coming to any professional, any MNC, big company or startup, whatever maybe, there are different job profiles are there. Okay, let me write down. Why it's making me disturb? Just 1 minute. Yeah. So you might have heard like long time back, like let's say a person is claiming that he's working or she's working as a software company. Maybe generally we call it as a software developer, right? Software developer or engineer, developer, or sometimes call it as software engineer, right? Now, what do you mean by that? It means that a person is involved in development of a software. Okay, software. Now, once development phase got completed, it will move to the testing phase. So this is development stage, dev stage in short I'm writing. This is kind of testing phase. They are doing lot of testing, like you might have heard about. Okay, your friend is working, or maybe your seniors are working, maybe as a tester. Like they are working in manual testing. Okay, automation testing. Okay, these are the different I can say profiles: manual testing, automation testing, and all together. Okay, one testing completed, it will move to production phase for the production deployment. That may be any cloud, maybe AWS cloud, GCP cloud, Azure cloud. Okay, these are the different cloud we use for the deployment purpose and all together. Clear? Fine. Now, this is the trend. Generally it was happens in the previous year and all. Now couple of years before, there is another trend coming in the market, that is called data. I mean, related to data, let me tell, this is my data. Related to data, lot of newly evolved job profile come in the market. Okay, So based upon the data, there is a profile called DA. DA stands for data analyst. Similarly, there is another profile called DS. DS stands for data scientist. Similarly, there is another profile called this is DS. DE, data engineer. There is something called AI, artificial intelligence. Okay, AI stand for artificial intelligence. Similarly, we have machine learning engineer MLE. Okay, MLE, machine learning engineer. Similarly, deep learning engineer. Okay, lot many things. MLOps, machine learning operation like DevOps. Okay, lot of other things also. Okay, I'm not writing. I mean, lot of different job profile come into the market. Just depends upon data only. That's why some people call it that data is the oil. Nowadays, data is the oil. 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 Why? Without oil, nowadays, I mean, obviously now EV vehicle come into the picture, but think about before coming into EV vehicle. Without oil, there is no existence of any vehicle. Means a vehicle cannot move from one place to another without oil. It may be petrol, maybe diesel, or maybe whatever it may be. Okay. Nowadays, obviously, we come to the market, so obviously, based upon the battery and all, obviously, things are happening. But now, before some years, when before EV came into the market, EV vehicle come into the market, obviously, I can say so. Oil was taking care of the entire automobile industry and all. Similarly, based upon the data. So we are talking about this data engineering part now. So whatever things we are going to see, we are highlighting and we are seeing about what are the roles and responsibility of the data engineer, what generally they did. Okay, so as part of data engineer responsibility, let me write down few responsibility. D means data engineer. First and foremost thing, what they will do building data pipeline. By using data pipeline, they have to extract data from source system. Guys, clear? Source system. Okay. Now, once they will extract the data from source system, what is the next step? Okay. Data cleaning, handling, missing values. Data cleaning, handling missing value. Okay. Handling missing values, data cleaning, data mining, data pre-processing, ETL part, ETL. So basically, ETL taking take care of the extract. Obviously, we have done. So transformation. Let me put transformation. transform the data, all the transformation logic they have to implement. Then they have to find in the data and store the data, store or load the data into target table. Okay, transform the data, store or load the data into target table. Clear? Data cleaning, handling missing values, data mining, data processing, transform the data, store or load the data into target table and all. Clear? These are the typical work of a data engineer. Obviously, initially all the things they are taking care of the on premises, as slowly, okay, as slowly cloud come into the picture. Okay, they move to the cloud, so they're using different cloud services to complete all these use cases. Clear? These are the typical responsibility of a data engineer. Now, I think you are feeling very comfortable to get into all these subtopic one by one. We'll see what is data collection, part of data storage, processing, data consumption, data visualization, and all this. Okay. Part of data visualization also we are using. So coming to data visualization, we are using different tool. It may be either Tableau or Power BI. We are using either Tableau or Power BI, or like we are using Zeppelin. Okay, a different kind of different tools also we are using. Even if Python giving some data visualization things like Matplotlib, Seaborn also we are using. But these are the third-party tool, okay, which we use for data visualization purpose. Clear, guys? Any doubt so far? Any doubt so far? Now, introduction to data engineering infrastructure. Now, overview. Data engineering is the practice of designing and building system to collect, store, process, and analyze the data. Why it matters? It is the backbone of any data driven organization, enabling analytics, reporting, AIML initiatives, and decision making. Now, coming to components, data collection, gathering data from various sources, data storage, ensuring data is organized and scalable, data processing, transforming data into usable insights, data consumption, making data accessible for analysis, machine learning, and other uses. Okay, now key component, key technology in data engineering, as I told you, let's say core technology, cloud computing platform. Different cloud provider we are using, as I have already written in my whiteboard. Either AWS or Google Cloud, Azure Cloud provides scalable infrastructure for storage, computing, and security. Similarly, data processing framework. Coming to data processing, we are using different tools like Apache Hadoop, Apache Spark, Apache Flink, crucial for big data processing for batch and streaming data. Now coming to database and data warehouse, a relational database either MySQL or PostgreSQL, NoSQL like MongoDB or Cassandra, data lake like Amazon S3, Azure Data Lake, and data warehouse, Google BigQuery, Amazon Redshift, and all. These are the things we are covering. Okay. Now coming to ETL tools, Apache Knife, Talent Airflow for extract, transfer, load operation to automate data pipelines. Now there is real-time data streaming. Apache Kafka, AWS Kinesis, allow real-time data streaming and event processing. So these are the different core technology we use as part of the data engineering. So let me come back, go to the next one, that is phase one, that is data collection. How we are collecting the data. Okay. Data collection is the process of capturing data from various internal and external sources. Data is collected in different format also and from various systems. Key technology and key techniques and technology, either batch collection or real-time data collection. Okay, what is batch collection and what is real-time data collection? Let me explain in the whiteboard. Okay, let me come back to the whiteboard. Coming to key technology or core technologies. Okay, first one is cloud computing platform. Second one is data processing framework. Third one is database and data warehouse. Fourth one is ETL tools. Fifth one is real-time data streaming. Okay. Now, coming to cloud platform, as you know, either it may be AWS cloud or GCP cloud or Azure cloud, any other cloud we are using. Coming to data processing framework, either we are using Hadoop or we are using Spark or Flink. These are the different framework we use as part of the data processing framework. Now, as part of database and data warehouse, we are using either MySQL or maybe Oracle. It may be Snowflake. Okay, maybe Teradata. Okay, it may be Cassandra. Okay, maybe MongoDB. Clear. Now, as part of ETL tool, there are different kind of ETL tool like we have Airflow, Apache IP, Talent. Okay, we have Talent, Apache IP. Okay, Airflow. Okay, real-time data streaming. Okay, we are taking care of Kafka, Spark streaming. Spark streaming and all. Okay. These are the different tools and technology we use as part of the core technology altogether. Now coming to data collection. Okay. Now as I told you, like coming to data collection. So basically, whatever the job we create in the real time, it is of two types. Okay, it is of two types. One is batch job, another one is called streaming job. What do you mean by batch job? Based upon the batch size, I collected the data from different source system. Like for example, I have scheduled a job. It should run at 3 p.m. hourly job. Then again after 1 hour, that is 4 p.m. Then 5 p.m. it will run like this, and it will run at that particular timing only. That is called batch job. But coming to streaming job, it's kind of live streaming data. Means uh, the job will be running 24 by 7, kind of listener, event listener. As soon as any upstream team people, they keep the data in the Kafka topic, immediately the Kafka consumer will consume the data from the Kafka topic. Okay, so this is a kind of real time data. Real time data processing. Here, there is no certain time for that. It will be always running. It may be come data may come at 3:15 p.m. It may be come at 5:20 p.m. Next data may come at 5:38 p.m. Maybe there is no constant data. This is for today's. I'm telling. Tomorrow may be different. Maybe tomorrow it's coming at 3, let's say 26 p.m. Maybe then after that 6 to 8 p.m. Maybe like that. You skip all these things. It's not like that. It will run in every hours like 3 o'clock, 4 o'clock, 5 o'clock, and so on. No, nothing like that. Clear, guys? Any doubt so far? Any doubt so? Yeah. So key technique and technology. So batch collection. Collecting data at regular interval, as I told you. Regular interval. It may be hourly job, maybe quarterly job, maybe weekly job, weekend job, weekday job, and all. Example, nightly batch job. So every night it will run at particular timing, let's say 9 p.m. or 11 p.m. or something like that. For processing that do not require real-time data. But coming to real-time data collection, capturing and processing data continuously. Key for system that require immediate decision making. That is fraud detection, recommendation engine, and all. Now, collect data collection challenges. Challenges in data collection, data consistency, ensuring that data from different sources align in format and structure, data volume and velocity, handling high volumes and speed of data, especially in real-time scenario, data quality, dealing with incomplete, noisy, or unreliable data, latency in real-time system, minimizing delay between data collection and processing, integration, integrating data from multiple platforms, system and formats, solution and tools, data quality checks, using algorithm to detect and remove anomalies, distributed system, tools like Apache Kafka and Google PubSub help scale data collection system. Now data normalization, standardizing format and structures for consistency. Use of API and a webhook to ensure seamless integration of real-time data streaming for the multiple services altogether. Okay. Now phase two, data storage. Data storage refers to storing large volume of raw and processed data in system designed for scalability and security. Types of storage. Relational databases like SQL, good for structured data with a relationship. Example, MySQL, PostgreSQL, and all. No SQL databases like for semi-structured and or unstructured data that needs scalability. Example, MongoDB, Cassandra. Data lake, large storage repositories for raw and unprocessed data. Data warehouses, optimized for querying and analyzing structured data. Key consideration. Scalability must handle growing data volumes. Performance data must be quickly retrievable for processing and consumption. Security and compliance. Data must be stored securely and in compliance with regulation like GDPR. Okay, these are the different key takeaway and different storage layers we are using. So coming to NoSQL, we are using either MongoDB or Cassandra. Coming to SQL, either we are using MySQL, Postgres SQL, or maybe Oracle, whatever name. Okay, now coming to different file system for big data. Coming to data lake, we are using Amazon S3, SDFS and all. Used for storing raw on-transform data from a variety of sources. Ideal for large-scale flexible storage need. Example, Netflix uses Amazon S3 to store its enormous catalog of media content, including streaming video file. Relational databases, good for structured data that require relationship indexing and quick access. Example, Uber uses relational databases to handle user and trip data. NoSQL database best for semi-structured and unstructured data, ideal for scalability. Example, Cassandra is used by Instagram to store user profile data, messages, and feeds. Clear? Now, what are the different challenges? What are different challenges that we face as part of data storage? Okay. Coming to data storage, now fasting data growth. Ensuring that systems scale as data volumes grow. Data duplication, preventing redundant data storage and minimizing the storage cost. Data security, ensuring that stored data is secure, especially in cloud environment. Performance, balancing high performance with a large data set. Example, slow queries due to large volume of unindexed data. Now solution, data partitioning, splitting data into manageable pieces to improve performance. Example, partitioning table in relational databases. Data archiving, moving older, less access data into cheaper, long-term storage solution. Encryption and access control, protecting data from unauthorized access and altogether. These are the different challenges that we face as part of data growth, data duplication, data security, and performance. And as part of solution, we're providing as part of data duplication or growth, we are using data partitioning, data archiving so that data security we can get. Performance encryption also we can use as part of the data security and all. Okay. Now, part of phase 2, phase 3, that is data processing. That's clear? Any doubt so far? Now, overview. Data processing involves transforming raw data into actionable insights. This is where data is clean, structured, and enriched for analysis. Types of data processing. Batch processing. Large scale data processed in batches. Example, processing sales data for reporting at the end of the day. Real time processing, that is, data is processed as soon as it is received. Example, fraud detection or recommendation system altogether. Okay. Now, key tools and framework. Like as I told you, Apache Spark we are using for distributed data processing for both batch and streaming data. Apache Flink we are using for only real-time streaming data. Hadoop we are using for large-scale batch processing framework. Getting my point? Okay, so these are the different tools and framework we use as part of the different type of data processing. Now tell me, coming to batch processing, how many options are there? Two. Either by using Hadoop or by using Apache Spark, we can do it. Correct? Now coming to streaming data processing, again there are two options are there. Either we can use Apache Spark or Apache Flink also we can use for real-time data processing. Clear, guys? This part of generally the semester exam or maybe in the interview question they may ask. Okay, so let me write down in the whiteboard. Coming to batch data processing, either we can use Hadoop or we can use Apache Spark. Okay. Similarly, coming to streaming data processing, either we can use obviously Apache Spark, no doubt, Apache Spark, and here we can use Flink, Apache Flink, Apache Flink, Flink. Why I'm writing Apache and Apache? Apache basically I can say company. It's an open source company which contributed a lot to the software industry. Like you might have heard about Apache Tomcat server, Apache, let's say WebLogic, or maybe Apache Spark, Apache Flink. I mean, lot of framework tool it provides as part of the open source contribution. Okay, so that's why as the company is providing the, that's why I'm putting the name before any software tool like Apache Spark, Apache Flink, and all. So what you learn from here generally, guys, Apache Spark is used for both. Spark or Apache Spark is used for both streaming data processing as well as batch data processing. But when I'm telling only batch data processing, I have to consider with Apache Spark with Hadoop. But when I'm talking about streaming data processing, I have to take care Apache Spark with Apache Spark. That means Hadoop you cannot use for streaming processing. Similarly, Apache Flink you cannot use for batch processing altogether. Getting my point? Any doubts so far? Any doubts so far? Please let me. Yeah. Any doubts so far? Please. If not, let me go to the next slide. Yeah. Coming to data transformation and cleaning, as I told you, as part of data transformation, we are implementing the ETL, extract, transform, and load. So extract, transform, load, basically extract data from various source systems, that is extraction, transforming it into the fit target format, maybe JSON format, maybe CSV file format, maybe PARQ format, ABRO format, whatever the format is required based upon the client requirement. You have to fit it, you have to transform it and load it into the destination source or data warehouses. Now coming to data cleaning, as I told you, is taking care of data cleaning also, removing duplicate record, filling missing value, handling missing value, standardization format, normalization format, everything it will take care. Now data enrichment, enriching data by combining it with external data set or applying business logic. Now, tools for data transformation. Apache Airflow, used for scheduling and automating ETL workflow. Now, AWS Glue, a serverless data integration service for transforming data. Now, real world example, Uber, transform raw data to clean structured data set for use in reporting and analytics. Now, you can see the real time versus batch processing. The real time versus batch processing. Real time processing, data is processed as it arrives, offering immediate insight. Example, AWS Lambda and Apache Kafka handle real time data streaming for applications like fraud detection and recommendation. Now, coming to batch processing, data is processed in large volume at scheduled interval. Example, daily, weekly, and all. For example, we can use Hadoop MapReduce handles large data set for generating aggregated report. Similarly, real world example, Google uses real time processing for search suggestion while generating batch report for analytics and all. Okay, that's all about the difference between real-time data and batch processing. Even if in the whiteboard, while explaining, I am giving a clear-cut difference. Batch processing means at certain interval, it will pick the job, it will pick the data, maybe 4 o'clock, 5 o'clock, 6 o'clock, or maybe 2:30, 3:30, 5:30, something like that. But real-time data processing does not have any constant job, constant timing. As soon as the data will be loaded, automatically or immediately it will start consuming the data. So there is no fixed time for that. Okay. Now, data consumption. Data consumption refers to how end user, a system or application access and use process data for analytics or decision making. Now, types of consumption, as I told you, let's say it may be business intelligence BI, dashboard, report, and KPIs for business analysis. Example Tableau, Power BI, and all. Machine learning ML process data is fed into algorithms for prediction. Example recommendation engine, anomaly detection, and all. Real-time application data is consumed instantly for decision making. Example fraud detection, consumer experience monitoring, and all. Now, real world example. Walmart uses BI tool to analyze inventory levels, sales data, and consumer behavior to optimize supply chain decision and all. Here, guys, now consume data like in terms of visualization. Okay, data visualization helps in presenting data in a way that is easily interpretable by stakeholders. It makes insight accessible to non-technical users. Okay, non-technical users. Key tools for visualization, as I told you, we are using Power BI, Tableau, we are using Zeppelin, here also trailing Lookers, D3.js JavaScript, enable interactive dashboard and report. Real-time data dashboard, we are using provide live insight for operational decision making altogether. Now, real world example, Salesforce uses Tableau to allow user to visualize customer data and sales trend altogether. Okay. Now, consume data consumption for machine learning. Machine learning and data consumption. Machine learning model data is consumed to train model for predictive analysis. Real world example Amazon uses data consumption from product purchases history to build a recommendation engine and predict future buying behavior altogether. Okay, that's all about the data consumption for machine learning technique. Now, consume self-service analytics for user. What is self-service analytics? Empowering non-technical business users to explore and analyze data without needing to rely on data engineering team. Tools for self-service analytics like Tableau, Power BI, Looker allow users to create their own reports and dashboards. Example, Zoom provides its user with customizable analytics and insights on meeting data without requiring IT involvement. That's all about self-service and analytics for user. Okay. Now, what are the different challenges? That is very, very important. What are the different challenges we face as part of data consumption? Now, part of data challenges, data overload. Too much data can overwhelm decision making because if data volume is too high, too large, it's very difficult to take the decision actually. Overwhelm. Data accuracy. Ensuring the data is accurate and trusted by the user. Make sure the data is accurate. Very less amount of data should be missing. If missing value is more, then handling missing value will be too difficult. At that time, data accuracy will be, or maybe mismatch and all. Access control. ensuring that sensitive data is only available to authorized personnel. Solution: data simplification. Using data aggregation and summarizes for easier interpretation. Role-based access, ensuring user only see the data they are authorized to view. Okay, role-based means you are giving the permission, read access or write access or modify whatever. So the role-based access, ensuring user only see the data they have authorized. Who have you are providing the authorized, they are able to access the data, not the other people. For security reason, you have to give all these roles and all. Now, end-to-end data engineering workflow. As I told you, I have already discussed in the study of my data engineering roles and responsibility. Data collection, gather data from different source system like API, sensor, database and all. Like storage, use scalable storage like cloud, data lake, database and all. Process it, clean it, transform it, missing the handle the missing value, data for analytics like ETL processing and all. Then consume, deliver actionable insight through dashboard, model by using Power BI, Tableau, or machine learning model, deep learning model, and all. Example like let's say Spotify. Collect user actively data like listens, searches, store cloud-based storage for scalability. Processes, analyze data to create user profiles. Consume, deliver personalized song recommendation in real time. Now, best practices in data engineering. Key best practice: automation. Automate data pipeline to ensure accuracy and timelines. Scalability. Plan for growing data volumes and ensure system scalable appropriately. And documentation. Clear documentation of data sources, model, and workflow for easy understanding and maintenance. Data security. Use encryption and access control mechanism. So in the real world example, like Airbnb maintained a scalable and automated data infrastructure to handle high transactional volume data. Now summary. What are the things we have discussed as part of this second part of agenda? Data engineering is fundamental for building a scalable, reliable data infrastructure. Key phases: data collection, storage, processing, consumption, and all. The real world example is highlight the importance of each phase and the technology used. QA, open the floor for, obviously, that is not part of the agenda. Okay, fine. So these are the things that we cover as part of today's discussion, guys. Any doubts so far?